and this is Technical Debt Must Die. If you caught Steve Smith talk earlier, he was talking really more about the technical aspects of technical debt. I'm going to be talking more about the communication and management aspects. There is a little bit of overlap, and if you didn't catch Steve's presentation this morning, I highly encourage you to watch it on demand later on. But let's get started. So last year, I went to a new doctor, and they gave me a mountain of paperwork to fill out, and it had a couple interesting fields on there. They had this occupation and any known occupational exposures. Well, at the time, I was a software engineering manager, so I put that. But a couple things about me. I'm a bit of a troll, and my wife wasn't there with me. And so I wrote down technical debt and legacy code as the occupational exposures. I thought it was pretty funny, but the nurse was less than amused. And I tried to explain to her the dangers and the realities of technical debt, but she didn't really understand. Technical debt is a real thing, however, and it really does impact us on our day-to-day lives as developers. And while it might not have been important for me to communicate to the nurse what technical debt is, there are some very critical conversations that we often have as developers with business stakeholders where we need to convince them that technical debt is a reality. So really, that's what I'm going to be talking about today is how do we quantify it, how do we communicate it, and how do we pay it down in a way that we can get results. So once again, I'm Matt Eland. You can follow me on Twitter at IntegerMan. It should be in the footer below. And just a little bit about me. I've been developing code since about 1987 in one form or another. Primarily, I've been working with Microsoft technologies, released .NET since Beta 1, and then JavaScript technologies since it was fun to write JavaScript, which was a while after JavaScript was initially introduced. I later went on to management, and I tried to earn this mug. I don't think I came close, but you can talk to my former employees and see if they would dispute that. And then recently, about 2 months ago, I left coding and management altogether to join John over at Tech Elevator, where I get to instruct on software engineering. We have locations all over the Northeast United States. We have Cleveland, Columbus, Cincinnati, Pittsburgh, Detroit, Philadelphia. I am an instructor in our Columbus campus, and I love it. It's fantastic. But we also have now remote options as well throughout the United States, as well as a brand new remote option in Charlotte, which is pretty cool. Incidentally, if you're looking to join or know someone who wanted to join a remote startup or a remote boot camp, we are enrolling, I think, in midsummer, about mid-July. So there's still time to go to techelevator.com and apply. But enough about them. Let's talk about technical debt. So this talk is really sort of the culmination of my experience in software engineering and just as a manager, kind of looking at what code we have and trying to figure out how to be a good steward of this code and how to advocate for it and measure our technical debt and just improve the code over time. So today we're going to be talking about how to understand technical debt and help others understand it. And then how do we analyze data to build recommendations for paying down technical debt that actually make sense and can get the results that we're after? And then how do we work with management in a kind of a respectful relationship with them to pay down that technical debt effectively and in a way that they can understand and appreciate? And just a note here, when I say management and business and things like that, I'm talking about the non-developers in the organization. So different organizations are going to be different as far as like how they're partitioned, but typically you'll have developers and then non-developers. So when I say management and business, that's who I'm referring to. Developers are part of the business, and they should be part of the business, and business should be part of development. A note here on questions. If you do have a question, please put it into the chat in YouTube. I will be looking at that out of the side of my peripheral vision over here. If you start your question with the word question in all caps, I'll be more likely to see it. But we'll also have time for questions at the end. So with that, let's get started. So what is technical debt? And I was looking last year for a good definition of technical debt, and I couldn't find one until I read this book by Adam Thornhill called Software Design X-Rays. And in it, he says technical debt is code that's more expensive to maintain than it should be. And I really love how simple this definition is. I particularly love the phrase more expensive because there are a lot of different ways that you can quantify technical debt. And the typical one we think of is development time. And yeah, technical debt makes it take longer to develop code, but there's also a morale cost. So it sucks a little bit more to work with bad code. And there's parts of our applications that nobody really wants to touch. And there's also parts of our application that are really risky to touch. Maybe we don't have the right tests around them. Maybe it's just very hard to maintain. And so some of that expense can be added risk. So there's going to be more defects. Things take longer. Things aren't as fun. Those are the typical costs of technical debt. Let's talk about some of the causes of technical debt. And Steve covered this a little bit earlier, but I want to go over it again. So often business stakeholders will assume that it's due to lack of knowledge of the product or the languages on the side of developers, or just developers being lazy or making mistakes. And these things do happen, and these are instances of technical debt. But you also have issues where you make a decision to incur technical debt. So we say like, hey, we have this critical date we need to meet. We need to honor this business relationship with our partners. We need to ship something. I know that you want to do it properly, but we don't have the time for it. So we're going to cut some corners. We'll do it properly later. Well, yeah, you're incurring technical debt strategically there. And that's often the best type of technical debt to obtain, as long as you can actually pay it down later, which is typically not the case in my experience. You'll also get cases of requirements changing. So you think you're building something to do X, and you show it to product management, and they're like, okay, this is what I asked for. Now that I'm seeing it, I'm seeing that we need to also do Y, or we really need Z instead. And so you change your code. Typically, you don't throw away all your code and rewrite it. You adapt your code to do something that it wasn't originally meant to do. And when you do that, that's usually a little bit of technical debt. The other thing is kind of like a natural sense of entropy in software. So if I build something in My Awesome Web Framework 3, and then a year or two later, My Awesome Web Framework 5 is out, well, my code's still written in version 3, and it's got all the security issues that were identified since then. And now I have some pretty urgent technical debt, which I didn't really cause. I didn't make a mistake. It just sort of was discovered over time. So these are kind of the common causes of technical debt. And I do want to highlight that, we don't really want to focus on the actual causes as much as just understanding technical debt. So our focus shouldn't be on how or who. It should be on how do we resolve it? How do we communicate it? How do we work as a team? And have that healthy relationship. And yeah, it's important to look at causes, but primarily let's start with what and how to pay it down. Another way to look at technical debt is by using the financial metaphor. So this is a waterfall chart, and Steve talked a little bit about interest. So this is great. This is a case where we took on 5 hours of debt. We took a shortcut, and we basically saved ourselves 5 hours of development time. Right? That's the principal on our loan. And now we start paying little bits of interest. So technical debt is causing us to do little bits of additional work. So because we took the shortcut, now we have to do a couple other things to work around this issue. And we didn't think of this one case, so now there's a bug. We got to spend 3 hours patching it. And now we're kind of net even, right? So we got 5 hours of productivity gain, and then we paid it back in this interest. And we still have to actually properly implement this thing. So let's say we go in and we actually build it properly. Well, now we've lost a total of 5 hours net versus doing it properly the first time. You might look at this, you might think, hey, we shouldn't have done this. We shouldn't have taken that shortcut. Well, maybe. It depends. If we took the shortcut because I was feeling lazy one morning, then yeah, you're probably right. But if we were trying to meet a critical date for a client and the company would have gone out of business or lost a major deal, yeah, it's probably a pretty good piece of technical debt to take on. So here's the thing about this. I look at this slide and I think this is an almost ideal case of technical debt. Most technical debt doesn't get identified. Most technical debt doesn't get tracked. Most technical debt doesn't get resolved. It gets copied and pasted throughout your code base until you're swimming in technical debt and it becomes part of the structure of the application. And then you have code duplication everywhere. Changes take a lot longer. Remember that graph that Steve showed this morning, if you were present. The cost of change becomes greater and greater and greater as technical debt thrives throughout your system. Okay, so let's switch gears a little bit. I'm going to tell you a story because I like stories. So we're going to talk about a fictitious company called Cyber Drone Logistics. This is a package delivery company that operates via drones, and they are working in major metropolitan area. They're trying to scale up their operations, get acquired by Amazon or somebody similar. Again, fictitious company. And so they're developing drone hardware and software to really route the drones around and just deliver these packages. They expected business to be booming during the quarantine, but instead they're dealing with what they would call suboptimal performance. And suboptimal performance looks to them like packages are getting delivered to the wrong address, drones aren't returning to where they should be, they're running out of energy. Occasionally they are colliding with property or people, and just occasionally, the drones would spontaneously combust and burn down people's houses. As you might expect, people don't like that. They get a little unhappy when their houses were down, and so because of that, our management is unhappy, and they say to us, "Fix it." And so now we're going to take this hypothetical example, and we're going to take a look at some techniques to really quantify the data and go about actually paying down the technical debt that's really leading to these types of issues. In a more strategic way. Yeah, you can do some quick fixes, but I want to focus more on like the long-term meaningful changes that we can affect as developers and how to drive that conversation with management. So we actually have a lot of systems as developers that we can look at. I don't have time to talk about all of these things, but we have work items, support instances, time tracking systems, source control, build history, tests, analytics, code analysis tools, application monitoring suites, and then internal and external surveys are all some examples of pieces of data that really impact our day-to-day lives as developers. And I encourage you to look at all of these things and more that are meaningful to your organization. But the most important one for me, in my experience, has been looking at work item management systems. These are systems like JIRA or Trello or Azure DevOps, as the screenshot shows here. And what we can do in almost all of these systems is that we can run a query, and we can just search for a specific set of items, and then we can kind of export that out to CSV, and we can just do some pivoting on that. So we can pull our CSV of our issues into Excel or Numbers or Google Sheets, and we can put it into a pivot table. And we can start to look at, okay, well, what components have had the most issues in the last year? Okay, well, how many issues by month? Are there any trends that we can see? Are there any types of issues that keep recurring? And you can maybe start doing some additional data aggregation on these things. And so you can really just kind of nerd out and look for trends, look for things that surprise you, and investigate those further. Just really see what the data has to tell you, because it can tell you a lot. And you're going to find that your assumptions are not always correct. Secondly, I like to look at source control kind of as a way to augment my analysis capabilities. So this is a screenshot from GitHub. It's an open source library that I've contributed to in the past. And like many open source libraries, this actually has infrequent commit activity. So you have long gaps between commits, but then you have like sudden spikes of lines being changed or deleted. And with this, you can kind of say like, hey, we're having a lot of issues at this point in time here. Is there anything that happened? Well, yeah, okay, we just changed a whole lot of code. So you can say, okay, well, maybe we need more tests. Or maybe you're having issues over here and you say, okay, well, nothing changed, so maybe something external is starting to break. So source control can really start to guide your conversations about what areas might be more brittle and what behaviors might be more risky. So that's something to use kind of as a supplementary source. There's also a lot of good tools out there on just analyzing Git repositories. I would do a search for Adam Tornhill because he has some fantastic stuff out there. So some of the metrics I like to look at inside of code, and Steve talked a lot about code, so I won't be talking too much about the technical specifics, but I like to look at the lines of code. I like to look at the number of lines of code in a method, as well as the number of lines of code in a class or a given file. And I'm not looking at individual commits by developers because you don't want to measure developer productivity because people will game the system and it won't tell you anything. But you can look at the state of the overall health of the code base via lines of code. And what this can tell you is, like, hey, this is a lot of lines of code for this method. I don't care how well it's documented. Or this class has so many lines of code, it almost certainly violates the single responsibility principle, which Steve talked about earlier. And so both of these things are factors of like, okay, it's going to be hard to keep this entire thing in my mind, so I'm more likely to break something, or it's going to be harder to maintain it over time. So lines of code is something I like to look at. Another one I like to look at is the very unfortunately named cyclomatic complexity metric, which Steve also talked about this morning. And cyclomatic complexity is just a fancy way of saying the number of unique paths through a method. So if you have an if statement, the true path and the false path are going to be, they're going to add to your cyclomatic complexity. And the higher the cyclomatic complexity is, the harder it's going to be for you to understand it as you're maintaining it, and the harder it's going to be for you to test it. And so that means your code is going to be more brittle over time. So cyclomatic complexity is one of those things I like to look at. A disclaimer on that, it does overemphasize switch statements. So if you have a switch statement with like 15 things that all do about the same thing, you cyclomatic complexity because like your code is awful when it might be very maintainable. There's a metric out there called cognitive complexity, which kind of de-emphasizes switch statements a little bit, but that one is more proprietary. So you can do a Google search for cognitive complexity and learn a little bit more about that. One of the other things I really like is you can take these two metrics, lines of code and cyclomatic complexity, and you can put them together onto a tree graph. And it's going to look something like this. And I know it's overwhelming, so sorry. But if you look at this, the individual size of a rectangle is a method. So each rectangle here is going to be a method. And the size is going to be the lines of code. And the color is going to be the cyclomatic complexity. So things that have low cyclomatic complexity are green and high cyclomatic complexity are red. So what this lets you do, and this is a tool called Independ, by the way, for .NET code. And what this lets you do is it lets you quickly show your boss and like, hey, my code hurts right here. Like, this is where it needs the help. And she'll look at that and she'll say, oh, well, yeah, okay. Why don't you spend a couple hours this Friday and just clean up those two methods? And then everybody's going to be happier. That's just at the small scale, though. While I'm talking about Independ, I do recommend them just for communicating to technical stakeholders, not necessarily for business stakeholders. They have a lot of really cool internal graphs that they just released that will just auto-analyze your code and give you really good visuals. It's a commercial tool, but I do recommend that you check it out if you work with .NET code. So let's switch gears a little bit. Let's talk about how do we analyze our data. So now that we have all these helpful metrics from our work item systems and all these other sources that we looked at, how do we really start to interpret this and analyze them? So what I discovered last summer was this little thing associated with Six Sigma. And I'm not a Six Sigma guy. I don't really know that stuff. But I found this was helpful. It's called the 7 Basic Tools of Software Quality. And these are just these little graphical tools or techniques that you can use to analyze your data. And so with the 7 basic tools, you can kind of pivot on your data and you can start to really just make sense of it all. You don't have to use these. You can use one 8 times. You can use one 0 times. You can use them in any order. These are just tools in a tool belt. Okay. So getting back to cyber drone logistics, they're looking at their drones and they're like, okay, we're having issues. So let's look at the average number of issues per day for our drone models. And so you can see here, like this is a histogram. So we're grouping things into little buckets. So these are the percentage of a drone having an issue over a course of a day. So we see model 1 has about a 7% chance of having an issue on a given day. And then version 9 has less than a 1% chance. So looking at this, you can say like, look, okay, our quality is consistently getting better. Our drones are getting more and more reliable. So we don't think this is necessarily a hardware issue. Like sure, version 7 had some issues, but we're consistently getting better. So this is maybe not a hardware issue. Maybe we just have more drones in the field and that's causing more issues over time. Maybe we just don't scale up as well. So that's a theory. Whenever you have a theory, you can start to investigate it. And what you can do with that is you use a run chart. And a run chart is just a fancy word for a line chart showing data over time. So here is the number of drones in the field for our organization over the course of a year. And you can see, well, yeah, we started at 100 and we ended at 450. So we had a 450% increase in the number of drones. So we probably had a 450 increase in the number of issues, maybe. So I could take this back to my boss and I could say, like, look, we have a lot more drones in the field. We just think that the more drones in the field that we get, the more issues we're going to have. I could do that. My boss is probably not going to be very happy with me. So let's dig a little bit deeper. So let's look next at a control chart, and that's just a run chart with some statistics associated with it. So a control chart here would be the number of incidents per month, and this amber line down the middle is our number of incidents for that month. But then we have these three other horizontal bars, and that white bar down the middle, that is our mean. So this is our average value for the incidents per month for the year. Okay, and then the red bar and the green bars, or lines rather, are actually our one standard deviation up and below that mean. So what this lets us do is this lets us see things that cross these barriers. So these are really our anomalies. So we can look at this and say, like, okay, well, August, we had a lot more incidents that month. In September, we had a lot fewer incidents. So what's special about these months? Because it's not just random noise, because it's crossing standard deviation lines. And so this is where your data comes into play. So you might look at a lot of different data sources, and maybe you eventually look at your weather and you say, like, okay, well, we actually had a really rainy August and a really sunny September. So maybe our drones are, more susceptible to weather than we thought. And that's a pretty good theory. And when you have a good theory, you can start investigating a little bit more. And so we're going to use something called check sheets. And check sheets are just tabulated data. So here we have a kind of rows indicating the types of issues that our drones are having, and columns indicating the weather conditions that the drones are having those issues in. And I like to add data bars to these just because it helps the data communicate a little easier. It helps you interpret the relative values of things. It's an Excel sheet feature, but I believe it's in other tools as well. And you can look at this and you say, like, okay, well, we clearly have some issues in certain weather conditions that aren't present in other weather conditions. So yeah, we definitely do have some sort of a sensitivity to weather, which makes sense when you're thinking about things that fly through the air, right? But now that you confirm that, okay, we have an issue, why do we have the issue? And when you start to ask why, that's when I like to get out something called the fishbone diagram. And this is kind of an exercise that you would do with your team. You get them at a whiteboard, or a virtual whiteboard in this case, and you draw this kind of a horizontal line of the fish's backbone. And this is your central problem. The drones are having problems in poor weather conditions. And then you put some ribs on this, so like the types of problems that they're having: wrong address, collisions, not returning home, etc. And then you start asking your team why on each one. Why are we going to the wrong address? Why are we colliding with things? Why are we running out of batteries? And you ask your team, and you start putting the bones on the fish. So the team will say, well, it's because of this. And then you ask why on that. And so you start to get like a much more fleshed out fishbone. So you can start to see the skeleton of the problem that you're dealing with. And many of these things you're going to look at and it's like, okay, well, I know an immediate fix I could do for this. And sure, okay, go and do it if it's really cheap and quick. But I think it's also healthy to look at this and take a step back and say, hey, are there any themes? And well, this is a made up problem that I made up. So yeah, there are some themes. So in this case, we have some issues with server performance. So we're having a lot more performance issues on our web server in the rain. Well, okay, so if requests are taking longer and things are having to wait more, I guess they're getting blown around by the wind. That makes sense. Okay, so maybe if we improve the server a little bit, then maybe things would get a little bit better. It's a good theory. We want to investigate data like that. We can take advantage of something called a scatter plot. And that's just two-dimensional data. So each one of these little yellow dots is a day over the course of the year. So here we have the number of support incidents for the day, as well as the average CPU utilization. So I can look at this and I can say, okay, when we're 90% CPU utilization for this day, we had about 14 incidents that day. Okay, but when we look at this together, we can kind of say, like, hey, are there any clear trends? And you can see that this one does have, there's a loose positive trend. So as the CPU utilization goes up, we tend to have more support incidents. It's not very tight, but there is a loose association. So I can take this to my boss and say, like, look, if we can improve our CPU utilization on the server by 20%, we're going to have about X fewer issues for that given day. Let me spend some time profiling this and making some recommendations. And you'll likely get okay, go do it, because you supported it with data. And that's really important when you're trying to justify time, because developer time is expensive. So let's take a look at another tool here. And this is a much simpler one for communicating to business stakeholders. And this is a flowchart. So flowcharts are very process oriented, right? So here's a web API for controlling our drones. So this is how the drones get instructions to go places. So they talk to this API, they authenticate, they retrieve the drone route from the database for that drone. If they didn't find one, well, okay, let's route you to the nearest distribution center and you'll figure things out from there. Let's save it back to the database, and then we're going to calculate our drone instructions just to get you back to that center. And then we'll return the values to that drone. So flowcharts are very helpful for communicating processes and flows to people. So I can use a flowchart to help a business person understand things fairly quickly. Note that I'm not using unified modeling language or anything complex or technical. I'm not using class names. I'm not using method names. I'm just talking high level, what are we doing? And because flowcharts are kind of the Wild West, we can do whatever we want with them. We can start to add in things if we think it's going to help our case. So here I've added in the number of issues that we've had in each major bucket. And this is where the component field in JIRA can come into play. So like, oh, okay, well, looks like we're not having a whole lot of authentication issues, but we're having a ton of issues actually calculating the drone instructions. So we can look at this and say, like, yeah, okay, that code is very brittle, and whenever we change it, we're breaking a whole lot of other stuff. So yeah, we want to improve the data access layer, but our time is really better spent calculating the drone instructions. And you can kind of do some performance profiling as well, and maybe throw that in there as a percentage. So I can use this and say, like, look, here's where our problems are. This is where we want to focus our efforts. This is what we think we're going to get as a result. Can we do this? And when you support yourself with data, you can really help you out, or you really help yourself out in making your case to the business. The final basic tool of software quality I want to talk about is the Pareto Chart. If you're familiar with the Pareto principle, paraphrased poorly, it says that 20% of the things cause 80% of the issues. Poor paraphrase, but that's essentially what it says. And what this is really is this is a vertical bar chart sorted from largest to least. And what you want to look at this is say, like, hey, which things, when we add them up, total 80%? And that's what this green line is. So here it's saying, like, okay, server performance is about 30% of our total issues. Okay, well, server performance plus communication delays, well, that's about 60%. So this green line is kind of a cumulative thing. Okay, and now we add in code is error prone, and we hit about 80%. And what did I say about 80%? Yeah, 80% is what we want to target. So looking at this, we can say, like, hey, if we can resolve these three things, we're going to resolve the vast majority of the issues that customers are seeing. Like, yeah, we could improve the motors and the camera and invest time in the hardware for that, but we're going to get more bang for our buck if we can focus on these three things. So I can take this slide, really minus the green line and this little red line I added as a visual aid. I can take this slide here and I can show it to management and say, like, look, we have these problems. We want to focus on these problems. We think that's going to really help things out. If that doesn't give us enough traction, we'll reevaluate at that point, but this is a good first step for us. So that's the 7 basic tools of software quality. I believe there's actually about 9 of them because people can't agree on what some of them actually are. So I showed you all of them. But let's talk about actually presenting this to management, because you can't just say, hey, burn everything to the ground. Side note here, I don't know why I have so many fire metaphors in this presentation. I'm pretty sure I'm not going to be a pyromaniac, but I'm not convinced. It's probably a good thing that I'm staying at home right now. But apologies for all the fire metaphors. I'm not really sure what was going on there. So when you do talk to management, you need to have a goal in mind. And your goal is actually not to get them to say yes. You want them to say yes, but your goal is to have a healthy and productive conversation. You want to have a relationship of respect and trust with them. That is your primary goal. And so you really want to understand where they're coming from, and you want them to understand where you're coming from. You know, because you're part of the same business, you're part of the same team, and you should be part of the same team. It shouldn't be development and management. They should be the same thing. Well, different jobs, but the same team. So you need to understand where they're coming from, because somebody like a product owner, they have to say no a whole lot. There's a lot of people who say, I want this feature. I want this feature. I need you to fix this bug. And this doesn't demo that well. And they're constantly saying no or not now all the time. I've listened to them before, and I've actually developed a lot of empathy for that. And so when you're telling them, like, look, I need to take some developers off of this project for a month and fix something, they're hearing, okay, well, what can't I say yes to? What do I say no to now? And that's hard. I mean, they're used to it, but it's still hard because they always want more. And there's a reason they want more. They want to help people out. They care. And you have to also remember that in the back of their head, they're wondering, okay, well, are you the right person to be fixing this? Are you the person who broke this to begin with? And if I let you do this, are you going to be causing more problems? You have this problem, which I'm not sure I really understand. And if I've let you go in there and fix it, are there going to be some more urgent problems that I do understand coming out of that? So do I really trust you? And again, that's where the data comes into play. If you can show them that you did your homework, that you care, that you are a professional, that you know what you're doing, you're more likely to get a yes, or you're more likely to get them to listen to you at least. And that's what you want. So let's talk about a presentation. So you really want to take somebody aside and say, look, I've got something I care about. I've been looking at our numbers. Can I take 30 minutes of your time and just show you some concerns I have? And you should get a yes. If you don't, have some conversations with your manager and see what you can actually do to bring about that conversation, because it's important. But when you do have that conversation, you want to keep it brief. So you're going to have no more than 15 minutes of slides that you're going to show them, if you're showing slides at all. If you do show slides, I'd start with an agenda with like, hey, this is what we're talking about. I have recommendations to improve the server performance, kind of your bottom line up front. Then you're going to give them a little bit more orienting information, such as what are the problems people have been having and what's the process that I've been going through to analyze this. You're not going to go over the 7 basic tools of software quality, but you might say that, yeah, I looked over all the issues from the last year. That's all you say. They ask questions, you can answer them, but that's all you say. And next, you're going to get into kind of the meat of your presentation, which is just, here are the major problems that we have. Here's my recommendation for each one. And you're going to give a simple visual that represents that problem. Could be a pie chart. It could be the Pareto chart that we talked about, minus that little green trend line or summary line. It could be something else, screenshot from code analysis tools, whatever it might be. But each one, you're going to say, hey, here's my recommendation to fix it. Very simple business recommendation. Targeted performance improvements. Improving our unit tests around this area. Improving developer training on problem X. That kind of a thing. And then you finish it with a summary slide. It's like, hey, summarizing, here are the 3 major recommendations I have. I need 5 developers, 1 month, a case of Mountain Dew, and a pony. And then you say, what do you think? And you wait, you listen, and that's hard, but you need to listen. This is not you saying we must do this. This is saying I have serious concerns. I want you to understand them. What do you think about my concerns? You know the business context more than I do, and it might be a hard conversation, and that's okay. You want to have the conversation. You want to have that relationship. That's your goal. Another note on people. People have different personalities, and those personalities do matter. So you're going to have some very type A people who really just the facts, please. Like, give me high level information. If I want more information, I'll ask you questions. I'll drill down in, and I'll get a little bit more. Then you're going to have some people who are very analytical, and they'll love to go over your spreadsheets and say, hey, okay, I want to talk about the high level. I'll send you all my data later. I'd love to nerd out with you over this. I'd love to see what you see in this that I might have missed. But right now, let's just talk high level, but I'm happy to give you all the data you need. And then you're going to have some people who are focused really more on people. And I don't mean that as a slight at all. It's just they can look at data and they can understand and appreciate the data. But the thing that really compels them is how it matters to people. And this is where stories come into play. This is where you say, like, hey, last sprint, it took us 5 extra hours to work on this because of this duplication everywhere. This feature just doesn't work right, and it caused a lot of other bugs. So you're grabbing a lot of anecdotes that are really mattering to customers and internal users, developers, things like that, and you're sharing those with people. And that's often what's very compelling to managers and things like that. Very people-oriented people. So some other tips for you. Anticipate the types of questions that you're likely to get. If I have the director of quality assurance in the room with me, they're probably going to ask, what they'll need to retest or what my plan for not breaking things is. And they may not be polite about it either. So you're going to get some very pointed questions. You're going to get some very pointed comments. My advice to you is, again, keep in mind that your goal is that respect and trust. And I advise you not to reciprocate in kind. You know your business better than I do. You know your coworkers better than I do. But handle those questions gracefully, even when you don't get that professionalism and that emotional filter from the business. And do be prepared for a no, and you might get one. If you do get a no, I recommend that you try to understand where they're coming from. So you want to understand, okay, I understand that you can't do this right now. Can you tell me a little bit more about your thinking on this? Like, do you understand the problem? Can you tell me what's more important? Do you think we can get to this at some point? And just really start to understand that in a professional and respectful tone. You're not trying to convince them at this point. You're just trying to understand their no. And what I would then recommend that you do is you start a different conversations. Like, okay, look, I'd like to start a new meeting where we meet together once a month or once a quarter, and we're going to go over the risks that we have as an organization. This is where you get out something called a risk register. And a risk register is just a tabulated collection of risks with probabilities of occurrence and impact if they do occur, and some priorities. And then you can kind of look at this over time. You can say, like, okay, well, let's tack on the number of issues that were caused by this risk. And these are, very understandable risks that are simplified so that a business person can understand them, right? Like this should be meaningful to the people that you're presenting it to. And then you're going to track the number of hours you lost to each issue over time, the number of defects that arose because of it, the number of features we couldn't do, whatever it might be, right? So you're going to have columns for this, and you're going to start to track it over time. And what you should see is that it's going to help it click for your business people. They're going to say, oh, this thing which I didn't understand, this really is costing us. So we really are losing a whole lot of developer productivity to this thing called technical debt. I had no idea that duplication was causing all these bugs. I just thought you guys were bad developers. And so once it starts clicking with them, it's going to start becoming important to them. And when it becomes important to them, guess what you're going to be asked to work on? Hey, could you fix that duplication issue? I'd really like this module to be more stable. When new bugs do occur, they're going to say, oh, that's because of this, isn't it? Not because, oh, you didn't study your code. And that's where you want to be, right? So this will help others understand things more, and it will help people see the value of resolving the technical debt. So let's talk about some strategies for actually resolving technical debt, particularly in an agile environment. I love to use the metaphor of crop rotation when I'm talking about technical debt. So when I'm looking at technical debt, I say, like, hey, in farming, if I keep farming the same field season after season after season after season, and I don't give it time to rest and recover, well, guess what? I just sucked up all the nutrients out of the soil, and now I'm getting nothing but weeds, and my harvest is getting lower and lower, and my workers are getting more and more frustrated. Same thing is true in software development, right? We don't pay down our technical debt. Guess what? We're getting more bugs. We're getting less features. It's just the facts of life. And this is a metaphor that really helps people understand it. Now, taking this literally, we could say, okay, every few sprints, we need to take to leave fields fallow. So we need to, just do a normal sprint. And okay, now we're doing nothing but paying down technical debt. That's the literal translation. I don't think that this is very feasible, because product managers always want to have something. They always want to be able to meet somebody's needs, and needs are often very urgent. And so the only time I really see this working is around major holidays, when maybe attendance around the office is light, or you're not expected to ship a whole lot. That's when these types of technical debt sprints can work. There's also seasons where you're waiting for a new deal to come through, or things like that. But that's generally the exception to the rule in my experience. A more healthy translation is probably just saying, hey, instead of every few sprints, we're going to do technical debt. Every sprint, we're going to do a little bit of technical debt, as well as a lot of product work. And this technical debt capacity that goes into the sprint, well, that might change based on your needs as an organization. But here you have basically the product owners are prioritizing 90% of your normal work, and your engineering leadership are putting in some pieces of technical debt into every sprint, paying it down. So that's often a good way of doing things. The thing you have to watch out for here is if you always do the normal work first, it can often run to the exclusion of the technical debt, because product management will often find urgent things to put in at the end of a sprint, and you don't get to the technical debt, or you don't give it the attention it deserves. Conversely, if you do the technical debt first, well, sometimes that can push out other normal work. And so you do have these competing forces in there. So one way to combat that might be to take a member of your team for any sprint and saying, all you're doing this sprint is technical debt pay down. So I want you to just go to town on whatever you think is the most important, or whatever we agreed as a team is the most important piece to pay down. The rest of us are going to handle everything that product management wants. And the next month, the next guy is going to do it. The next gal is going to do it. And so over time, it's a bit of a mini vacation for your team members. Like, okay, great, I get to do technical debt this sprint. And if that team member comes into work and says, okay, I'm going to fix this thing which I really hate, and another dev comes over and it's like, look, I got to maintain this thing which you usually maintain. So can you fix this? Can you help me out? This is where you start to get people understanding the value of cross-training a little bit more and teaching others more about the code. So that's often very helpful, I find, just for teams. One thing that I like to do is, and Steve talked about this earlier with the Boy Scout principle of, when you're in a code base and you're working with the code, fix things in that area. So if I'm fixing a typo, I might improve the formatting of a method. If I am adding a new class, doing a little bit more work, I might do a little bit more cleanup in related areas, places that consume it. So I'm doing a proportional amount of cleanup around the areas that I'm changing. This is helpful because the areas that change the most frequently are going to get the most attention. And you already have quality assurance resources understanding that these areas need to be tested anyway. So that's helpful. One note on this, I would definitely recommend that you communicate this is what you're doing to product ownership. So don't try to hide the fact that you're cleaning up things. Just say, look, as I'm working on things, I'm going to be doing a proportional amount of cleanup just to keep our code fresh. There's going to be some times when we need to take some dedicated action as well, like take out portions of our sprint capacity. But this will help us more avoid that and help us have a higher velocity long term. While we're talking about making changes, let's talk about test plans. Whenever I'm getting a commit from someone, the first question I ask, beyond even is this the right thing, is how do I guarantee that this is not going to break something? How are you guaranteeing to me that your code is not going to break production when it gets out there? And the answer to that might be unit tests. It might be that you did some manual testing around it. It might be, hey, here's a Postman script to test it. But the important thing is that you've thought about an answer, right? If you can't tell me how your code's not going to break anything, I'm probably not going to accept your pull request. Spoilers. But you just do need to think about it. See question. I see a lot of this, typically with people advocating for responsibility, taking on tech debt because getting the product out is more important than tech debt in some cases. However, does that mean the parts of the software are buggy or slow or other issues? Are there any studies assessing long-term the losses due to perception of quality versus meeting deadlines? Patrick, that's a good question. I'm not aware of any specific studies. I did like the cost of change slide that Steve Smith had this morning. I would encourage you to watch his talk once it comes out on video demand for that. I'm not aware of any concrete studies, but there likely are many. So sorry, I can't answer that off the top of my head. Experientially, I will tell you that technical debt, it does matter, and it does matter a lot for software quality in particular, but also for development team speed. Okay, so with that, let's wrap things up here. So getting back to Cyberdrone Logistics, they were able to convince management of the importance of paying down technical debt around their web APIs drone instruction calculation method. They added a lot more tests. They did more performance improvements. They scaled up the web server. They did all the things they should. And the problems, by and large, disappeared. They dropped their dream of being acquired by Amazon, and they started expanding into new markets. They also started expanding into new areas. So they got into robotics as well. And they're doing some really cool things. one sad note about them is that too many houses burned down. That marketing decided they needed to rebrand the company. So they're now known as Cyberdyne Systems, but they have some really cool things ahead of them, and I'm very excited to see where things are going to go. Terminator references aside, if you do adopt these practices, which I do recommend, you should expect to see an increased level of trust and respect and understanding between the business and development. You should understand that developers are going to be more equipped to be able to meet the organization's need, particularly long term, and that when you do pay off your technical debt, which you will be able to do, you will be paying off the right pieces of technical debt. This is something I've thought about a lot over the last year. I actually spun up killalldefects.com with over 100 articles on software quality, particularly around technical debt. Everything I talked about today, there's generally an article or two about. So do check that out at killalldefects.com. Finally, I do want to thank Christopher and Missy and CouchConf and just for throwing on this event. It's not often I get to have a conference talk wearing sweatpants with a blanket on my lap. So that's pretty cool. Do also want to thank Improving and Zag for sponsoring this event. It's just really fantastic to be a part of. I will ask if there's any questions. There's a slight delay, so please type them in. I will hang around and see if anyone comes in. We do have a few extra minutes, and I do have some bonus content if we don't have any questions, but I want to make sure that we address any questions that people have that didn't get addressed before we get there. All right. Well, if you do type in a question, I will be able to answer it. But let's move on to bonus mode, right? So let's talk about some visuals. So if you have a slide, make sure that your visuals, are understandable. I've seen slides like this in business presentations. It's very hard to understand if you can't tell. These are all like what games have you played the most? The answers are all Breath of the Wild. So normalize your data. That's important. I have a question come in. What's the single biggest mistake programmers make when asking about correcting technical debt? That is a good question. I have seen programmers make the mistake of, actually, this ties in well with my next slide. When you're talking to an engineering manager trying to get them to understand technical debt, you need to understand what they're thinking about. So if I'm talking to my boss, and my boss is our director of engineering, and they in turn will need to convince the CTO or product management or somebody like that, they're going to be asking themselves, do you know what you're talking about? Is this really a problem? Is your solution the right way to solve it? Are there things going on in the business that might make your solution irrelevant? And that kind of thing. And assuming all of this is yes, then they need to ask themselves, is this worth me risking some of my reputation to talk about? So is this worth me going to bat for you? And sometimes the answer is yes, and sometimes the answer is no. If you don't like the fact that you're using try catches and finallys instead of a using statement, probably not worth going back to bat for you. If you don't like your brace styling, probably not the right thing to go to bat for. But if you have some urgent concerns, yeah, it's probably good to go for that. Other question: isn't determining this management's job? This seems similar to something I've seen done in a different field as a manager. So yes, determining whether technical debt is worth taking on is management's job. However, management doesn't look at code typically, like product management, COO. They're not in there looking at code. They don't have that programming education typically. So they may not be able to understand it to the degree that you understand it as a developer. They're also not in there working in it day in and day out and seeing how it impacts your job as a developer. So while yes, it is their responsibility to advocate for it, it's really going to be the people who are on the front lines who have to start bringing it to other people's attentions. And I would also stress that to do it with respect, right? So you want to have that respectful tone to you. We do have 2 more minutes, so more bonus content. So yay. I love monitoring tools, exception monitoring services like Raygun or Rollbar or LogRocket, App Insights, things like that. If you can hook your application up to be able to like track the errors over time. You might get management saying like, look, everything is on fire. Again, with the fire, I don't know where it comes from. I'm sorry. Everything's on fire. You need to pay it down. You start fixing this, stop doing what you're doing. Well, you can go into your exception logging solutions and say like, okay, yeah, 2 users are having an issue, but we have 100,000 users right now. This is really not as big of a problem as you're making it sound. Or conversely, support might be getting some calls and like, hey, there's some weird squirrely stuff going on. And then you look in and it's like, oh, okay, well, we have massive exceptions going on under the covers. Let's take a look at this. And so you can kind of look at that, and the data will help you prioritize issues correctly and taking really emotion out of things, and helps you diffuse emotion as well. Question, have you ever sought treatment for your pyromania? I would ask that we please burn that question. I don't want to address it at this point in time. I have a request to keep going for another 2 or 3 minutes, so you get more bonus content. So yes, Christopher, let's keep going. Kind of related to monitoring tools, we have analytics. So we can actually track the amount of issues that come in or the amount of usage of different areas. So maybe product management is saying like, hey, we really need to improve this area over here, and maybe 2% of your usage is going to that. It could be that, hey, if we improve that area, we're going to get 30% of our usage going into that and all these new customers. But it could be that, oh, okay, well, maybe we should really just focus on this thing over here instead. So Google Analytics is something that I would really recommend that you investigate, just to really understand user behavior at an aggregate level. Kind of my final recommendation here is this little library that I've fallen in love with called Scientist. I have a whole nother talk on scientist.net. You can look me up on YouTube at Matt Eland, and you'll find this talk. But I really love Scientist for just paying down issues safely. So with Scientist, you call out to the Scientist library. Scientist is going to call out to both your legacy routine and an experimental new routine. And it's going to return the results of the legacy routine and ignore the results of the new routine. And where this is helpful is that if you see an error in your new routine, well, the user doesn't see it, but you do get to log it to like your exception management solution. And so then you can kind of safely patch it behind the scenes. And once everything is ready, you get rid of the legacy routine, you go with the new routine. Scientist is available in so many different languages. I feel like I'm not explaining it properly in this short amount of time. But do a search. I'll put a link into chat later just for my talk on scientist.net. I really recommend it if you want to safely pay down technical debt. Christopher, let me know if you're good. Otherwise, I have a little bit more content. Always good to have extra content around. Okay, I'm going to keep going. So another thing I love is jest style pending tests. So with pending tests, you are kind of trying to pin the current application's behavior in place. So I'm writing a test. I'm serializing the results of that operation to a JSON file. And then later on, I'll be able to compare it. So let's say I'm talking to a loan application system. So here I'm storing the results of a particular request, and I'll save that in kind of a unit test, and then I'll be able to rerun it later on and say like, okay, well, everything is different. So with this case, your test is going to fail, and then you can pretty quickly get a handle on, hey, something's changed that I don't really have a specific unit test for yet, but we can't really ship this because the behavior's changed. You'll check in that JSON file in with source control. So Jest has snapshot tests for this in JavaScript. In .NET, there's also a Snapper library, which is basically the same thing. So that's Snapper for .NET. And I believe that is about all the time that we have. So thank you again, CouchCon, for having me. It's been a real treat. I'll be around in Slack afterwards. The link to Slack is in the description. And I think after lunch, Matt Groves is going to be giving a talk here on Couchbase. So Matt is actually a co-organizer with me at Central Ohio.NET Developer Group. So thank you again for having me, and enjoy the rest of the conference.